Department of EEE France Xavier Engineering College, Tirunelveli welcomes you all. Electrical and Electronics Engineering Department was started in the year of 2002. The department is functioning with two PG courses such as Power Electronics and Drives was started in the year 2011 and Power System Engineering was started in the year of 2013. We got recognized research center status from Anna University Chennai in the year 2017 and our department reaccredited by National Board of Accreditation, New Delhi from 2017. The department has a strong faculty strength who are committed and are specialized in various streams of electrical engineering. Also, we have DST, FIST supported Advanced Power Electronics and Drives Laboratory and National Instruments Power LabVIEW Academy. Good evening to one and all present here. It gives me inner pleasure to welcome you all for this webinar session. The webinar title is Electrical Control Engineering. This webinar is hosted by the Department of EEE in association with France Xavier Alumni Association. On behalf of our Chairman Dr. S. Gretas Babu and our Managing Director Mr. Arun Babu and General Manager Development Dr. Jayakumar and our beloved Principal Dr. Velmurugan and Director of Alumni Association Mr. Krishna Kumar and our Department Head Dr. P. Annapandi. I heartily welcome all the faculties and the students of various institutions and industry experts. I am very happy to introduce our guest, Mr. Chinnadurai Chellasamy. He did BE in University of Bradford, UK. He worked in Lucas TVS in Chennai for 2 years. He personally explored career opportunities in India and abroad. In 2000, he migrated to Singapore with new job opportunity with Lysia Instruments, Switzerland-based company, and worked as engineering assistant for 6 years in the manufacturing of optical products and microscopic and survey instruments. He moved to another great opportunity with US MNC Baker Hughes Oil and Gas Company, formerly known as General Electric Company. We are currently working as Operations Manager to lead supply chain function. Prior to this role, he had handled several internal opportunities to develop his domain expert in technical as well as operations management to support for the oil and gas customers. He is serving the industries of oil and gas customer across the globe and leading all global project manufacturing execution. He got several employers award within the business for his initiative and accomplishment. Now I hand over the session to our guest, Mr. Chinnadurai Chellasamy.
Good afternoon, everyone. Welcome to this webinar. Today topics we are going to discuss about electrical and control system. Before I go introduce myself, I want to thanks to all the participants, especially Karpagavalli, who has invited me to join this webinar, and she is assistant professor with Francis Xavier College, Tirunelveli, and working as in an electrical and electronics department. And by the way, I am Chinna. I am the lead operations manager, working Baker Hughes company as a digital solutions business. In fact, we are an oil and gas company based in Singapore. So today discussion as more interesting subject. In fact, especially me, I had a very passionate subject, and electrical and control system. You know, in modern industries, control system is everywhere in terms of any product, anything in a large scale equipment or even home appliances, and everywhere you are able to list it for the numerous control systems, and each control system has a unique features, and of course, and it is all engineered product to meet the market demand and also simplified our day-to-day life in terms of optimize the outcome from each equipment, and it is widely used as appliances from everywhere. So this subject is going to be a very a detailed one, and I will be able to share my experience uh, through these sharing sessions. And first of all, this control system topics, why I choose, you know, I have been learned and I have been taught from various new technologies and advancement of software development in a control solution industries. So I had passionately learning. So I think I wanted to share a couple of my sharing experience with you guys. Electrical control systems, as for the today learning objectives, I'm going to cover for the system theory. Of course, in a college curriculum, we all have to learn the fundamentals from the theory. The fundamental nowhere goes wrong. That's a important pillar. Of course, it's a foundation for every one of us. We come through. So kindly try to pay attention about to understand the logics and theories in a brief manner. No need to be very complicate those theorems. Uh, Control theory has a very simple principle. We are going to see in the later slide. Types of control systems. We are going to see the overview of how many control system type available in the market and widely used, and applications of control systems, and DCS control systems. DCS control system and its importance I will be covering the slide. Turbine control system, modern solutions of control system, and industrial leaders of control system who so called as OEM of the products, and the product manufacturer or the package seller, they are the OEM. DCS architecture of power plant, digital controls, distributed control system architecture in a power plant, how it's used. Um, it's not in a very detail. It's going to briefly tells you about how the you can imagine how the plant has been set it up. Preparedness for the career opportunity. So I will be sharing my experience and tips to you, and it's I believe strongly it may be helping you to certain way to shape your career in this industry. Control system. What is control system? The name itself very clear. Control system is a arrangement of physical components in a row or the series to form to get a desired output, providing an input. That means equally input. The system is control the inputs and deliver the outputs. That's a representation in the graph. Sorry, the block diagrams. And for the that's a very fundamental. Its scope everyone is clear. The next chapter is types of control systems. Linear and non-linear control systems. Linear control system is a theory. Non-linear also is a theory. And linear control system theory applies systems made of device which is obey the superposition principle. I believe you guys learn about the superposition principle. It's a very detailed notes to understand the logic behind, but I kindly request you to refer back what is the superposition principle in a separate offline notes. And linear differential equation are governed by this system. So linear control theory applies, and it's obey for the superposition principles and governed by the linear differential equations. Whereas we compare to non-linear control theory, it does not obey for the superposition principles, and it is a real system. The earlier one I said the linear control is ideal as a theoretical system, and non-linear control is a real world system, and it's a, you can see in the real world system atmosphere in everywhere are all non-linear type, and is governed by the non-linear differential equations. Current slide, any system we are first question we have to ask is an analog system or a digital system. Analog system and digital system you are seeing in the screen. Uh, Analog is a continuous system. It's formed like a wave signals that change with a period of time. In the graph you are seeing from here, you are starting from 0, and this 0 has to go to the signal value is increased. It is definitely has been moving upwards whenever the signal increase. Also it is progressing in a waveform to over the period of time. This is a continuous system, and digital system is like a discrete system. Discrete is basically as a binary systems. Just assume it's like a 0 in the system. 0, it's go as a 1 as a value. 1, 2, 3 like that. So the next level it's again is maintaining in the 1 to 0 the steady state of 1. So this is called as a flat. So again is rising up as 1 then 0. This is the way we need to understand the block diagram or the graph to understand the logic behind. And any system is like an digital input or digital output is for the digital system. Analog input or analog output is an analog systems. Hope is clear. Types of applications. uh, Control system applications are the so it is widely used in variety of industries, and I have major classified the most important industrial segment. Aviation and aerospace industries is autopilot applications, missile guidance systems, and space vehicles and target tracking is a radar in fact. This from the aviation industries. As a very interesting fact in technical magazines or the engineering magazines, a lot of experiments happening around the world to autopilot even a car. Even we are seeing in an aircraft autopilot cars are already as on the road in a few cities in the US. That was we are reading in the news. More or less, the industrial demand and the innovations, it will reach the milestone um, very soon. Is widely available in the market. Automotive. Automotive is a makes sense for discussing here. I think for me, that's what I feel. And India is a automobile industry giant, one of the automobile industry giant in the world. So the globally the leading companies, all they have the major of the locations or the position they secure in India. So India is producing a lot of vehicles and for internal domestic purpose and exporting. So it's a huge range of applications involved, especially in India for the automobile industry. The control system has contributed significant value to the industry. So it makes sense to learn. Then for the home appliances, home heating, for the heater in a cold countries they have the home heating setup. How we do the aircon setup in uh, like countries in Singapore or India, we need the cold countries they need a heating elements. Automatic washing machines, refrigerator, microwave oven, and toaster. This all has been home appliances for an example. Plant operation and manufacturing industry. Automation, industrial automation as replacing many things in the world. Uh, it's another subject. Um, it's covered like an uh, disposed people are doing the job. The robotics are employed to manage such operations or the industrial controls. CNC machines also as an control system. There is a language is Fanuc or any Japanese languages also as the control system languages. And industrial and power plant. Industrial has to be like non-stop machinery is running in industry. it has been governed by the control systems, like a large scale of spinning mills, for example, the modern spinning mill that has been uh, connected through some sort of controls, as well as the power plant. Among these uh, list of comparisons or the equipment where we apply the control system, power plant is as a very pivotal point for all over the industry, is widely and very popularly used uh, to all over the countries. So the next continuation on the slide, we will be going to talk about the uh, PowerPoint related informations. Before that, we move to turbine control system. Turbine control system, we have two type, gas or steam turbines. The right side on upper corner, there is a block diagram I have added. You are seeing for the there is an air inlet. It passed through. It's a compressed air is to the compressor, and the compressor is compressing the air and deliver the output. It passed through the combustion chamber where there is an uh, the burning or the fuel burning happen for the gas turbine. This is a gas turbine, in fact. So the fuel burning is happen, then it is the releasing the hot air to run the turbine. The air is passed through along the uh, through the rotors. Rotors, how it looks, you can see in the bottom of the slide. This is one of the real turbine in industries, and the air pass through the roots of the blade, and it is creating a force to rotate the rotors from the turbine. It has coupled to the alternator to generate electricity. Of course, there is a prime motors available, starting motors we call as a prime mover. To kickstart the process, it will be turned on. This all is in line to the you can imagine how it is assembled in a real site. Of course, the gas is an exhaust to the atmosphere. So some system they have added additional gas turbine to don't want to waste the heat energies from the gas, and adding like an additional system to here pass through and run another turbine. So they may connect in a series or parallel, depends on the design. So here the important point, the engineering concept don't want to waste anything. You know, how much energy is spent to compress and heat up in the chamber. Even though it's complete in the first segment of its operation, there is an at least gas out, am I right? It's a hot air. So from the hot temperature, further heat up to an additional combustion chamber, then as passed to the second turbine. It's called as a T2, an example. This is the way it works. Um, this slide we are seeing a steam power plant. Steam power plant you're seeing as a more detailed graphical representation in this slide, and it is basically the air from the atmosphere and air heater, the fuel gas. Okay, it is the economizer as the fuel gas has passed through. Uh, Once it is the heating chamber as burning and heat up the boiler. The boiler is boiling, and the steam is an output from the boiler, and it passed through the steam turbine. The steam turbine as operate itself by the steam, and earlier I said for the escaping gas in the previous slide, am I right? Here in the steam, it is reheated to achieve the required temperature to the operating the turbine 2. It's the turbine 1 T1. This is turbine 2. This is a scenario I quoted before. So it's completing its operations, and it is once the exit steam is go to condensation, and the condensation has to pass through as like a water pump. So condensate it, then make up a water tank and it's a feeder feed water, again go to the feed water pump. The feed water pump has to pumping to through the economizer to the boiler. This is a setup. Why I go in a very detail about this control setup. Every segment area, a boiler area or a turbine area and a cooling system, and even for the feed pump control and a cooling tower, whatever the channels in the slide, all is required to monitor and operate by the some sort of control systems. That's why I go in very detail. So in every area there are least level of system has been placed and it has been connected to the dashboard or the control rooms in depth. Modern solutions of control system. What is HMI? This is a very important things. You heard about what is HMI maybe. It's the human machine interface. The name itself very clear. You know, machines are everywhere in the plant. So how we are going to talk to the each machines? HMI is a tool for the human interface. Then the machine connecting to the PC. HMI is a PC. It's a computer. This computer has been linked through network to various platform of the various sources of machines in the risk area across the plant. So all the machines behavior has been through network has been um, linked to the HMI. The HMI is capturing the events we call as the event. Machines like a compressor is running. The behavior of the compressor is we convert as in a technical term as an event. Micro events in a microseconds all capture how the machine is behaving. Any abnormality, there is a set points to control uh, to monitor it. The middle screen we are seeing like an uh, there is it is a modern technology. It comes with a touch screen in fact. So all the plotting you are able to see from the screen, from the various risk area we can able to monitor by the operator, and it is also capturing the record of data from the field machines, and this data has been used for analytics. Analytics as another important Hughes subject. So analytics also is very important for the machines to predict the machines propagation of failure or the event, or really the investigation point of uh, the diagnostic engineer they have to use. But we are not going to touch major in this analytics in this session. And the extreme right screen is you are seeing graphs. This is like line graphs. You're seeing a lot of spikes in the scraps. Uh, there is a set points to monitor and control it, and anything goes above the upper limit or the lower limit of the set points, and something wrong in the machines. So there are factorized differences. Uh, the engineer has need to conclude. So they will collect the data and do the monitoring and analysis. Basically, the HMI uh, it's a record of everything. That's what I want to say. It's tracking the events for trend analysis and the production time, and the event display all we can see, and it's a very useful machine. It's an essential machine as well. It's not a optional one. It's essential in the control systems. Innovative solutions in a DCS systems. DCS systems, this graphic representations giving you an overview. It's not like a simple setup, a DCS system. You know, it has been involved with a multiple component or the subsystem levels. So it is like the component involved as like a controller, network switches, firewall, servers, field devices, field bus, and field network. These are all the important peripherals to form the DC system to work healthy. And this is the modern setup. A typical DCS setup is like uh, this is communication layer. In this array, they may be formed. Let me explain the each component importance. Controller is a PCB board with a programmed firmware. Of course, you guys know. This controller has to program to apply the logics to control over uh, the, the desired expectations or the behavior of the machines. Network switches, of course, it is connecting through network through Ethernet cable uh, across all the machines, and you are seeing multiple desktop PC screens. You are seeing these all like a HMI or the historians all connected together in a mapping. So firewall is another important element. Firewall is so preventing unauthorized access from the external, and also uh, it is a barrier, in fact, to cannot be simply uh, over bridging the firewall or break through the firewall. That's kind of a tough security setup the industry has been in place now. And servers, as I said earlier, it is storing the data. And field devices, the numerous field devices available, and it is all connected to the field bus and the field networks. So field device you are saying is an individual device. Field bus is a row of arrangement, and like how we are seeing in the bottom line of uh, the diagrams, it shows uh, this is the area I want to highlight. It's a field network. We're talking to the multiple machines. This communication layer, as every industry we need to develop, but in terms we are talking about for uh, the technical establishment, but it's not like an very easy stuff to do it, and a lot of engineer involved to design these parameters or the setup to meet the outcome and ensure the plant is running is healthy. What may happen to the plant if I assume that would be any failure in this DCS system or any subsystems, any control systems, and it put the entire plant in a downtime. So any downtime is a productivity loss. So these machines are really as paid very expensive uh, price from customers or the solutions owners. So the solutions what has been sold by the companies also an expensive to meet the demand and the importance to to conclude the setup. Next topic is cyber security. Cyber security as why I highlight here as in a in a modern industries, any industries, not only in IT industries and machineries and the plant operations, all is need to be uh, managed by cyber security. Uh, as a industrial guy, I am seeing a lot of improvement and the new requirement coming from the demand from the market to the cyber security establishment. So cyber security establishment is essential for to operate it. I can tell you the good example, near Tirunelveli we have a Kodangulam power plant. This power plant recently attacked by hackers. That was the news we have read in the social media and in the news channels. Am I right? So how these attacks happen and what would be the impact? Maybe in a nuclear power plant is dangerous than anything else. So it can be destroyed the society, and it may be the immediate impact is a downtime. Don't assume that the reactor will burn or explode, and the fundamental it may affect the operation of the turbine and the power generations. So this is a critical uh, uh, operations to manage and feed the power to the society. So for the cyber security is in place, such a vulnerability we can prevent it. That's what I'm trying to say. So Maybe a question. Definitely there is a Kodangulam atomic plant. They may have the any power plant. They have the cyber security as complied. Even there are hackers, even smarter people. They break through the cyber security. So the cyber security firewall and the cyber security establishment as really as an essential to protect the uh, plant or the equipment or the setup. So it is this industry is creating a lot of job opportunity as well. So I will be just cover the opportunity segment as well. You know, you seeing from the graph, you are seeing like an secure, defend, contain, monitor, and manage. There are a level of certifications for the security technologies, and manage security technology, the next level certificates. So whoever is programming it in a low level to configure the machines and you know this establishment, it can be a uh, configure in the PC, also remotely can able to connect and monitor and ensure is everything in a healthy, that's a way. So whoever interested to know about cyber security, um, just please you can find a plenty of references in Google that will brings you to the right place where there is an cyber security courses available in a for the sake of learning, and you can explore it. Okay, uh, you definitely it's going to be an interest, and this upcoming modern world, this is going to be one of the demanding uh, uh, industry. This slide we are sharing the DCS architecture of nuclear steam plant. This architecture is mainly, as you know, the reason of my sharing, you can see lot of uh, areas in the plant we called as a risk area. And every risk area has been as an independent group. So we call them as to be as a risk area. The risk area has to monitor by the individual control machines. There are a range of machines available in every risk area. So can you assume like one power plant is to like 10 acres or 50 acres or 20 acres? There are a large space is occupied due to the multiple reasons in the safety and technical challenges. It has been dispersed across the overall plant. So each machine has monitoring in a specific area of the risk or risk area. So how we are going to monitor it? Really challenging, am I right? So each control system is running independently for the risk area. So we are integrating them through the distributed control systems. So all the subsystem or the risk area has been mapped to the DCS. The DCS has to as a master commander to to control overall the plant healthiness. Plant healthiness is one of the machine is down, maybe the subsystem will be down, and the main feeder will be interrupted. It's a chain effect. So every system should be well taken care of by the through the DCS connections. So the DCS is an essential system in any plant. It's a matter of a nuclear plant or on a general power plant. This is an important things to know. And we are seeing from the screen there is a operator simulator training. Something and interesting. We are selling various product to the various risk area, am I right? It's not only one company, it could be many companies. So the DCS system has a capacity to interact with a wide range of um, different systems and their subsystem as well. So the DCS as a compatibility, we call as a right term is a compatibility to involve to talk to various subsystem. Uh, so it has a capacity. So the DCS system as a we cannot play in a real time, am I right? So the real time is we cannot play. So every subsystem, let's say we are going to sell like a turbine control system or monitoring system. So what we'll do? We have to use a dummy value. So the dummy value, how we will develop, as of course amps and volt we are injecting to the machines to demonstrate the machine's behavior to record down. So simulator also doing such a job. The simulator is as a phantom machines. It is act like a machine. The real machines, we have to use it through the required connections to to the simulation purpose, and it is mainly involved in the training to the operators and everyone, so they can able to learn from this simulator uh, everything of the DCS systems. Okay. Then for the mapping is very clear. I don't need to add on more comment. I think the bottom two slides you are seeing is the control room atmosphere, and this is one of the sample only. Assume would be in multiple windows in every subsystem, and all the screens and plots has been is a detailed planned to the breakdown of every risk area. So all the machine signals has been displayed and creating alarm signal to the operator. We call it as an alarm signal. And anything is a machine is a healthy, it won't create any alarm. So it always looks as like a, you'll be able to see some green indicators. And for anything goes out of the range, like the user preference limit, USLV, user specified limit, USLV will say that. So if anything crossover, we will able to make a shouting like alarm screaming to the operator to to alert. Then the operator has to pay attention to how what's happening to the machine. So sometimes the operator itself they are able to troubleshoot in a simple form of in a basic troubleshootings, and also they are the engineers available to attend the fault. They can rectify the issues. Sometimes the issues as frequently happen, so we cannot just leave it alone, because it's me one day it will bring a bigger issue for the business or the plant. So what they need to do, the uninterrupted data, or sorry, the collected data periodically to be feedback to the next team as a diagnostic team in the next window. They do a analysis all the timeline events, and it's another huge interesting thing. They will be connect to the load. They will be take as a failure sequence. At the failure sequence, where is the chain of effects, and the inputs events or the delays happen across the system, they will be able to figure out and fix the problems uh, according to their the expertise knowledges. So this is the way the plant is operating. uh, you can take this message to any plant, chemical plant or the power plant. Even chemical plant, they have their own power generations in a large scales. So of course earlier I talks about the turbines, definitely they are using, and for the control system they definitely they need to in place. And another electrical part as a generator, as a excitation control system. This is it is ensure that uh, the power feeding has been happen is in a healthy state. So the exciter is also as playing in a very important role uh, in the whole setup. Okay, this screen you are able to see the control room. Control room as you are seeing multiple panels in the window, and it is one important point I want to highlight. Uh, it is assembled with a multiple electronic component. Am I right? Even the small setup of controller and circuit breaker, buzzer, and for a relays, and this is the master circuit breaker, and the uh, heavy load uh, machineries all has been in place. within the within the enclosures. So the all it has been programmed or the expected to produce an outcome as an immediate effect. Let's say the control room, it is earlier I said it's always alarming. So there could be in an industry, you're not seeing in only one place of this control room, even next to the machines you are able to see. In our natives, we are seeing a lot of wind turbine mills, and next to the wind turbine mills, every wind turbine they have their own controller room. Am I right? That's an example. So all may be sometime connected to one DCS control, but I'm not very sure about in a windmill how they are operating. And the important things, the modern control room setups are really as a quick access to essential information and easy to use controls allows faster operation action. This meaning is, and we are seeing our older generation of controllers and control system from the business in our industrial area, and we are comparing the latest developed one and the old one, and there are a lot of technical advancement to improve um, it basic from the hardware and even software improvement, all is integrated to make the operator or the user experience to be more comfortable and ensure it's in overall as a machine healthiness. This is a way the control rooms uh, playing an important role in the setup. Yes, this slide we talks about the industrial leaders of controls and automations, and you are seeing a major driver of industries: Siemens, Yokogawa, Johnson Controls, GE Power, Plantpacks, Honeywell, Emerson, of course, where I'm working, Baker Hughes. They are the market player for the controls systems and automations. So these products are, it's an expensive product, as like involved in a lot of technical queries and complexity to figure out the design and everything. So these companies are dedicated to serve the society or the globe, uh, to ensure our day-to-day lives are as moving normal. So if you are interested to do more about the basics and fundamental, you would able to uh, log in through internet. There are plenty of sources available to read and find yourself. Self-learning as a student, as a fresher, coming out from the graduation, you would able to start a good start before you are switching or entering to the real industries, start your career. So it really is will helpful to know, and you may keep remember these are all the generic um controls system pioneer in the world, and currently widely available in the market. So you can decide. So okay, next let me come to the job opportunities. Job opportunities has been, we can it is widely available. What is our interest in the industry, in the controls or automation industries? Are we going to be a design engineer, or going to be the solution provider, or as a maintenance engineer, or a test engineer, or program engineer? Anything. We have to uh, know the fundamentals thoroughly, that could be built from our our curriculum, where we are all learned from our colleges, and also we need to further develop uh, to improve your milestones, to reach your goals and experiments. So the first 2 years is a very toughest time to understand the overall plan. That's what I'm hearing from my field engineer. I seldom only have an connectivity to the field, and most of the field guys as a service engineer, they will be feedback to me, and a lot of things we share. So we are seeing as like a service experience also as a very important to gain the knowledge. So you have to decide which direction you need to be move on if you are willing to be a controls engineer. And that's all I am trying to highlight. And cybersecurity I had highlighted before. It's you can explore it. And even instrumentation industries also partially to be linked with control systems. So we can list out many things, the wide range of opportunities, and large scale of manufacturing plant. Also, you can focus your job searching. As a manufacturing setup comprised with this kind of control system, plenty of opportunity available in the market. So the choices is yours. I'm Yeah, that's all I want trying to share with you guys. Wish you all the best. First of all, thanks for your patience to to walk through with me this experience, and I believe somehow it's going to be help you this sharing experience. At the same time, as uh, you have to build your own career in the next level. Maybe if you have any doubts, anything from the slides or any clarifications, you can reach my contacts, and I would able to uh, answer your queries as my best. Unless I will be able to connect my technical team to help you certain basics. Of course, when you are entering to the industrial atmosphere, only you need a more detail of queries. But the fundamentals learning, entering to startup, I think this is good enough, and your theoretical knowledge is good enough. You keep learning, and I'm wishing you everyone as all the best and good luck. And most important things in a COVID time, be safe everyone with the family. Good luck, guys. All the best. Thank you.
Give thanks for a little, you are find a lot. On behalf of our chairman, Dr. S. J. Babu, Managing Director, Mr. Arun Babu, and General Manager Development, Dr. J. Kumar, and on the behalf of Triple Department, I extend my hearty thanks to Honorable Delegate who blessed us with their presence. I would like to extend our sincere thanks to beloved Principal, Dr. Velmurugan, for his encouragement and support. I would like to extend our hearty thanks to Mr. Krishna Kumar, Director of Alumni Association, for makes this webinar in a grand success. I would like to extend my special thanks to our beloved HOD, Dr. P. Annapandi, for making this event the grand success. I extend my special thanks to our resource person, Mr. Chinnadurai Chellasamy, Lead Operation Manager, Project Supply Chain, Material Manager, Baker Hughes, Singapore. I would like to thank all the participants and my special thanks to coordinators for their support. Thank you.